Okay, so we're here again, and the first thing is factors. Okay, so the three main steps to note about factors are on the board. So I'm going to read them and explain them. The first one being, for a number A to be a factor of a number B, make sure A is not greater than B. Basically, A to be a factor of B can only be less than or equal to B. The second thing, and the most important when checking if a number is a factor of another number, is A, if it's a factor of B, it should be able to divide B without any remainders. Okay? And finally, the third one is a general rule. When you're gathering factors of a number, automatically number 1 and the number itself are factors of that number. 1 and itself, that number itself, are factors of the number. Okay? So, we're going to go into checking factors. Okay? So, we're going to check, okay, the below questions, okay, in here. So we're going to check these three. If 7 is a factor of 35, first things first, 7 is less than 35, so it could be a factor. Second thing, we have to check 35 divided by 7 and make sure we have no remainders. Okay, so if we do this, remember the bossed up method. If we pick 3 first, 7 is bigger than 3, so there's no chance of that happening. So there's 0 7s in 3. And then we pick 35. Okay. Now, if we create the times table starting from 7 times 1 is equal to 7, you will end up, okay, I've broken this, you'll end up at 7 times 5 equals 35. Okay, so we don't need to go any further because we found something equal to 35. So the number we're looking for 35 divided by 7 is in column D for the line we've chosen. So that's 5. Put that other 5 there. Second thing, to check if there are remainders, we take the answer from column E on that line. 35, put it there, and subtract. Now we've subtracted, and that's zeros. Okay, so no remainder. So the answer is just 5. So yes. Okay, we can conclude. Okay. Now, to check the second one, 9 and 47. So is 9 a factor of 47? First things first, 9 is less than 47, so it could be a factor. Second thing, when we divide 47 by 9, do we have remainders? Okay, so let's carry out that division. Go here. We have 47 on the inside, 9 on the outside. Pick 4 first. 4 divided by 9. 9 is bigger than 4. That's not going to happen, so that's a 0. And we go for two numbers. 47 divided by 9. Okay. Now, we have to create, okay, the times table. Start at 9 times 1 equals 9. So if you keep going, 9 times 2, 9 times 3, you'll get to, I've broken this up, so you'll get to 9 times 5 is 45, and then 9 times 6 being 54. Okay, so we have no 47 here. So we're going to pick the line that gives us the answer, okay, in the E column, that's just less than 47, which is 9 times 5. And the number of 9s in 47 is in the column D on that line, which is 5. So we put that above 7. And to check for remainders, we take the answer in the E column on that line, put it there, and subtract. And that's a 2, and that's a 0. Now, there are no other numbers, so that's where we stop. So 47 divided by 9 is 5, with a remainder of 2. So 9 is not a factor. Of 47. Okay. Now, finally, 12 and 94. Is 12 a factor of 94? First things first, 12 is less than 94, so it could possibly be a factor. The second thing to check, does 94 divided by 12 produce remainders? So, carry out the division process. Start with 9. So 9 divided by 12. 12 is bigger than 9, so that's 0 there. So we go for 94 then, divided by 12. So you can create your 12 times table. Start from 12 times 1 is equal to 12. And you can keep running it down, but I'm going to break this up because I know where I'm going. So you get to 12 times 7. That gives you 84. 12 times 8. If you add another extra 12, you get 96. So there is no 94. So the answer in the answer column, less than 94, is 84. So we pick that line. So the number of 12s in 94 is in column D on that line, and that's 7. Put that above 4. And to check if they're remainders, we take the answer on that line from column E, 84, and we subtract. And that's a 0, and that's a 1. There are no other numbers there, so we've finished. So what we have with 94 divided by 12 is 7, with a remainder of 10. So 12 is not a factor of 94. Okay, now the rules that you can see on the board are some of the basic rules, okay, apart from the ones given above, that help if you're trying to find all the factors of a number, okay? These are my personal general rules that help if you can, by just looking at a number, you can know what factors exist within that number. So for example, if a number b, okay, ends in an even number, and an even number is 0, 2, 4, 6, 8, then 2 will always be a factor of that number. So for example, 48 ends in an even number of 8, so 2 will always be an automatic factor of 48. Okay? Pick any other number that ends in an even number off the top of your head. 54 ends in an even number of 4, so 2 is an automatic factor. Okay? Secondly, if a number b ends in 0, okay, that's an even number, so 2 is a factor. But also, if it ends in 0, 5 and 10 will always be factors of that number. Okay? So for example, 50 ends in a 0, so 2 would be a factor because 0 is an even number. But also, 5 and 10 will be factors because that number ends in a 0. Automatically. Okay? You don't even need to check it. Okay? And the third one, if a number b ends in 5, then 5 will always be an automatic factor. Okay? For example, 65 ends with a 5, so 5 is an automatic factor of 65, so there are no checks necessary. Okay? And you might be thinking, what about the rest? I think with time, as you keep checking factors of other numbers, you'll be able to work based off of your instincts, okay? Because these are the general ones you can get, but for the rest, okay, the way you're gonna have to do that is start from small numbers, okay, that are less than the number b, and divide b by that number, okay, and then check for remainders, okay? And as you work with more questions, you get better with it, okay? Okay, now let's find all the factors of a given number, okay? So for example, find all factors of eight. Okay, we'll start with that. Okay, the other numbers we will be doing today are 12, 33, 45, and 60. Okay, so let's start with 8. Okay, so first things first, there are 2 factors of 8 that we already know about, okay, and those are the factors that are for every number, which is 1 and itself. So 1 and 8 are factors of 8, okay. Second thing, 8 is an even number, so 2 is a factor, okay. Now, because 2 is a factor, we can use it to find another factor by doing this. If we divide 8 by 2, we can find the other factor connected to 2. Okay, so 8 divided by 2. Okay, we start 2 times 1, 2. Break it up because I know where I end up. So you get to 2 times 4 is 8. Okay, so I take that line from the D column. That's the number of 2's in 8. So I put that above 8 as 4. And to check for remainders, I take it from the E column of that line. So that's 8. Subtract. So zeros. Now, while 2 is a factor because there are no remainders, the answer up here is also a factor. So 4 is a factor. And so those are all the factors of 8. Okay? Now, for smaller numbers, you can do this, what I'm about to recommend, but you can't do it for much larger numbers. Now, if you do not trust that only 1, 8, 2, and 4 are factors of 8, factors of 8 are between 1 and 8. Okay? So, we've decided 1 is a factor, 8 is a factor, 2 is a factor, and 4 are factors of 8. If you want to check if 3 is a factor of 8, 5, 6, or 7, okay, you can do that. Okay, I'll show you how to do it for 3, and then you can check the rest. Okay, so if 3 is a factor of 8, then it should divide 8 without any remainders. So let's do that. 8, 3. So create the 3 times table. 3 times 1, 3. 3 times 2, 6. 3 times 3, 9. Okay, so there is no 8, but the smallest answer close to 8 is 6. Okay, it has to be less than 8, but as close as possible, so that's 6. So we pick that line, but the number of 3's in 8 we pick from this column on that line, so that's 2. And to check for remainders, we pick from that line, but from column E, so that's the answer 6. We subtract, put that there and subtract, so we get 2. So 8 divided by 3 is 2, remainder 2, because it has remainders, 3 is not a factor of 8. Okay? You can check 5, 6, and 7, but they are not factors as well. 5 creates a remainder, 6 creates a remainder, 7 creates a remainder. Okay? Now, the next number we want to check is 12. Okay? First things first, we pick the 2 general factors of any number, 1 and itself. Okay? Second thing, 2 is an even number, so if it ends in an even number, so that means 2 is a factor. So if 2 is a factor, we can find the other factor by saying that connects to 2, 12 divided by 2. Okay? So we pick the first number first, 1 divided by 2. 2 is bigger than 1, so that's 0 above 1. So we go to 12 divided by 2. Okay, we go down the times table of 2. 2 times 1 is 2. 2 times 2 is 4. So, if I skip through this, because I know where I'm going, I end up at 2 times 6 is 12. Okay? So that's an exact match in answer. So I shouldn't go any further. So I pick that line. Now from the D column of that line, that's where I pick 12 divided by 2. So that's 6. I put that up there above 2. And then to check remainders, I take it from the E column, which is 12. And then I subtract. That results in zeros. So 2, of course, is a factor, confirmed. But also, the answer up here is also a factor, which is 6. Okay? Now, another way to think about this is, let's try, okay, if 2 is a factor, let's check if another even number is a factor. I want to check 4, okay? I'm just going based off my instinct, okay, to check. So, to check 4 as a factor, I do 12 divided by 4. Okay, take first number first. 1 divided by 4. Okay, that's not going to work. 4 is bigger than 1, so put 0 there. Okay, so now we go for the both 12 divided by 4. If I go through that, 4 times 1 is 4. 4 times 2 is 8. And 4 times 3 is 12. An exact match, so I don't need to go any further. Okay, so I pick that line. Okay, so 12 divided by 4, I pick it from column D. That's 3. Put that up there. To check for remainders, I pick it from column E on that line. 12. 12 minus 12. Zeros. So, that confirms that 4 is a factor because there are no remainders. But the answer up here is also a factor. So 3. Okay? Now, in my opinion, okay, those are all the factors of 12. Okay? Now, if you don't believe me, remember, all factors, okay, have to be less than the number, less than or equal to the number. So they're between 1 and 12. So if you say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? Those are the numbers from 1 to 12. And we have concluded so far that 1, 2, 3, 4, 6, and 12 are factors of 12. If you believe that 5, 7, 8, 9, 10, or 11 is a factor, check it. Okay? 12 divided by 11, and see if you get a remainder. If you do, then it's not a factor. Okay? But I can guarantee you, you get a factor for all these numbers that were not picked. Okay? So, moving on to the next number to check for factors, all the factors of 33. Okay? First things first, 2 common factors is 1 and the number itself. So 1 and 33 are factors. So, based on instinct, there's a bunch of 3's in there. So I'm just going to jump at 3. Okay? I'm thinking 3 might be a factor. So, to check it, 33 divided by 3. Okay? So I pick 3 here first. So 3 divided by 3. Okay, so that's at the first hurdle of the times table. 3 times 1 is equal to 3. So that line is sufficient. So the number of 3's in 3, I pick from that column D there. So that's 1. Okay, that's 3 divided by 3. And then to check for remainders, pick it from the E column of 3. I subtract. So that's 0. Okay, but we've not finished. There's still another 3. So I bring that down. And I check again. 3 divided by 3 again. And the answer is the same. We go back to this line here. 3 divided by 3. We pick from the D column, that's 1 above the second 3. And to check if the remainders, pick from the E column, put that number there, subtract, that's 0. So there are no remainders. So 3 is definitely a factor. Also, the answer you get for the division when there are no remainders is also a factor. So 3 is a factor, but the answer we got, 11, is also a factor of 33. Okay? Now, I don't believe there are any other factors of 33, but if you believe there are, you can check between numbers from 1 to 33, check any number you think is a factor, divide 33 by that number, and see if it produces a remainder or not. If it produces a remainder, it's not a factor. But I think those are all the factors of 33. Okay? Now, we also have to check 45. Okay? First things first, there are 2 factors. Okay? General factors of every number. It's 1 and itself. So 1 and 45 are factors. Now remember, I said one of my general rules, personal ones, if a number ends in 5, then 5 is an automatic factor of that number. So 5 is an automatic factor of 45. Now to check if there's another factor, I say 45 divided by 5 to find the factor that goes with 5. Okay, so 45 in here, 5 out here, so we start with 4. 4 divided by 5, because 5 is bigger than 4, that's not going to happen. Put 0 here, and so we move to the 2 numbers. 45 divided by 5. Now if we create the 5 times table, that's 5 times 1 is 5. Okay, keep going. Times 2, times 3, times 4, times 5, times 6, times 7. And when you get to times 9, you have 5 times 9 is 45. Okay, exact match for answer. So we pick that line. You don't need to go less than. So 45 divided by 5. We take the answer from the line, from column D on that line, as 9. So put that there. And to check if the remainders from that line, answer in column E, so that's 45. And so we subtract, and that gives us 0. So that confirms that 5 is a factor, but we also find another factor, okay, and that's 9. Okay, now, that's not all. I think 3 is a factor, but we have to check it. That's only an instinct. So I have to do 45 divided by 3. So 45 in here, 3 on the outside. Start with 4 first. 4 divided by 3. That's a possibility. 3 times 1 is 3. 3 times 2 is 6. So we have to pick, there is no 4. Pick the line as a number just less than. Okay. So on column D, that's what we have for 4 divided by 3. So that's 1. Put that here. And to check if remainders, we go to column E for the answers column on that line. So 3. Put that there and subtract. So we have 1. But we haven't finished. There's still a 5. And we need to bring down. Okay. So now we have 15 divided by 3. Now if we continue, okay, the 3 times table, we go to 3 times 3 is 9, 3 times 4 would be 12, and then 3 times 5 would be 15. Okay, that's an exact match. So you pick that line on column D on that line, and that's the answer for 15 divided by 3. So we put that above the 5. And then to check if the remainders, we go to column E on that line, answer 15, and we subtract zeros. So yes, no remainders. 3 is a factor, and the answer to 45 divided by 3 is also a factor. So 15 is also a factor of 45. Okay? Now, if you think there are any more factors, okay, check any number less than 45. Okay? Check 44, 43, 42, 41, 40, or you can start from 1. You can check 2, 4, 6, 7, 8, anyone that hasn't been checked to see. But I can guarantee those numbers will not be factors. Okay? Finally, for the toughest one, or should I say just the longest one, 60. Okay, first of all, the easiest form of the factors are 1 in itself, so 1 and 60. Okay, now 60 ends in 0, so 2 is a factor because that 0 is an even number. Because it ends in 0, 5 and 10 are also factors. Okay, so I just need to find what connects to 2. So I go 60 divided by 2. Okay, so start with the 6. 6 divided by 2. Create the 2 times table. And 2 times 3 is 6. Exact match in answer. So we pick that line. 6 divided by 2, we pick that from that column there, so that's 3. Put it above the 6 up here. And then to check if there's a remainder from that, take the answer from that line, subtract, that's 0. Okay, now there's still a 0 left here, so we bring that 0 down, and so our next division is 0 divided by 2. Okay, and so that is simply just 0. Okay, so no remainders there, just a bunch of zeros again. Okay, so if 2 is a factor, because it produces 0 remainders, the number up here as the answer is also a factor. So 30 is a factor. Now, we can do the same thing with 5 that we found as a factor. So 60 divided by 5. Okay, pick 6 first. 6 divided by 5. So 5 times 1 is 5. 5 times 2 is 10. So we have no 6 in our answers. But the answer smaller than 6 and close to it is on this line, that's 5. Okay, so from this column, our best answer for 6 divided by 5 on that line is 1. And to check the remainder, from column E, okay, we pick 5 and subtract, put that here, so we have 1. So we still got 0 here, so we bring that down, making 10. So we have to find 10 divided by 5. Okay, we already have an answer for 10 here. Okay, that relates to this. Now 10 divided by 5, our answer is here on column D on that line, that's 2, put it above the 0. And to check for remainders, put the answer from column E on that line here, and we subtract. So that's a 0. So we can be fully sure that 5 is a factor of 60 But we can also take the answer of that division, 12, as a factor of 60. Okay, so now we're going to check for 10 as well. Okay, so we can find the other factor that connects to 10. Okay, so 60 divided by 10. Take your first number. 6 divided by 10. Too small. 10 is bigger than 6, so that's 0. Okay, we take both numbers. 60 divided by 10. So you can create your 10 times table. 10 times 1 is 10. 10 times 2. Add another 10 is 20. And if you keep going, you end up at 10 times 6 is equal to 60. Perfect match. Okay, so for the best possible answer for 60 divided by 10, you go to column D on that line. 6, put it above the 0 to check for remainders. Go to column E on that line. Take that 60, subtract, you get 0. Okay, so 10 is confirmed as a factor, but also 6 is confirmed as a factor. Okay, what else could be a factor? I see a 6 here and I see a 3 here, so I'm guessing 3 could be a factor, but I need to check it just to make sure. Okay, so let's check 3. Check if I'm right. So we have 3. 60 divided by 3. So we go for 6 first. Okay. 6 divided by 3. So if we go 3 times 1, that's equal to 3. And 3 times 2, that's equal to 6. So, perfect match. We can stop there. So, 6 divided by 3, the best possible answer we take from column D of the line we've chosen. So that's 2. Put 2 there. And from column E of the line we've chosen, the answers, check for remainder, we take that 6. Put it here, we subtract, that's a 0. But we're not done, there's still a 0 here that we need to bring down. So that makes for 0 divided by 3. Okay, that's just 0. 0 divided by anything is 0. So put a 0 there and a 0 below. That's just more zeros. So no remainders. So 3 is definitely a factor. But the thing is, if 3 is a factor, then the answer it creates is also a factor, and that's 20. Okay? Now, you might think we're done, but I still think if 2 is a factor, I still think there's a possibility 4 might be a factor. So let's check it. Okay? So, we go 60 divided by 4. on the inside, 4 on the outside. So we start with 6. 6 divided by 4. So 4 times 1 is 4. 4 times 2 is 8. So we have to pick the line with the answer either equal to 6, which we don't have, so we go for the number just smaller than 6. So that's this line here, and we pick from column D on that line. So that's 1. 6 divided by 4 is 1. And to check for remainders, we pick the answer from column E on that line. So that's 4. And we subtract. So that's 2. Okay. To continue, we bring the remaining 0 down. So that's 20 now, divided by 4. Now if you keep creating the 4 times table, 4 times 3 is 12, 4 times 4 is 16, but 4 times 5 is, behold, 20. Okay, perfect match. So we pick that line, and from column D we take our best answer, 4. 20 divided by 4, which is 5. We put that above the 0 up there, and then for column E we take that answer to check the remainder. So we put the 20 here, and we subtract. That's 0. So no remainders. So 4 is a factor of 60. Now, but the answer it creates, 15, is also a factor of 60. Okay? So I think those are all the factors of 60. If you think there are more, go from numbers from 1 to 60, apart from the ones I've chosen, and check if there are any factors I haven't gotten. Okay? But that's the idea. Okay? If you think a number is a factor, okay, divide it. If it produces no remainders, then it is a factor. If it produces remainders, then it's not a factor. Okay? Hope you got that. Thank you very much. You've been listening to the Math Zone, and until next time.